This is a video about chart calibration. The end result of calibrating a chart is to get a 2200 size letter to the proper dimensions based on the exam room configuration. The typical method is to measure from the patient to the chart screen. And so it's the exam chair to the screen where it's projected. This projector aims directly at the chart screen. When calibrating a chart, I typically start off with the distance from the chart screen to where the patient sits in the exam chair. This long tape measure I typically make as the end point where the back of the chair joins the seat of the chair, and then find that point on the tape measure, which is about between 143 and 144 inches in this exam room. The other factor is how far the screen is from the wall. If it's screwed flat into the wall, then it's the distance to the wall. In this case, there's where the middle of the chart is about 2.5 inches from the edge of the screen to the wall. So the distance as measured here, 144 inches, should actually be more like 142 inches approximately. So we'll use 142 inches, which is 11 foot 10 inches, as the chair to chart distance. So to calibrate for a room like this, it's between 11.5 and 12 feet. So it should be around 51 millimeters height of the 2200 letters. And if we look at the calibration of the 2200, we find it's like 55 millimeters. So 2020 in this room is a lot easier than 2020 in a standard room by 5 or more % of the height. This is a Marco projector which has focusing controls by this knob and this screw. And I'm just showing you the way the focus changes by moving this lens. So I've loosened this knob. Now as I move the lens in, it's tremendously out of focus. And as I move it out, it's now coming into focus. I go beyond that point, and again, focus changes, and then I can settle back to where it's in focus. Now this one is a telescoping adjustment that changes the size of the image. It also changes the focus. Now I've moved it all the way backwards. And now I've reset the focus with the front lens. And let's see, I'll measure the relative size. So this measures nearly 100 millimeters tall for the 400 letter with the lever all the way back. And moving all the way forwards, it's way out of focus. And then as I move the front lens, I reestablish the focus. And now with the lever all the way back, it's now like 70 millimeters for this 2400 letter. So the true measurement is probably going to be somewhere in between. Now the way this is installed is either self-standing with its own platform with this ball socket that hooks onto a base, and then that sits on a shelf. In this exam room, there's a bracket which is designed to hold that ball socket on the front here. So these are two American-sized Allen wrenches, which snug up against this anchoring ball socket. Now, you don't want to tighten it completely because you've got to get all the adjustments done. So from here we then have to get the 2200 letters, which is the top row, both in focus and the proper size. And I've predetermined it should be about 53 millimeters high. 53 millimeters high for the 2200 letter. So my first guess was incorrect, it's like 48 millimeters. So I need to expand the size, which would be by pushing that telescoping lever further back and refocusing. So my second attempt here puts it about 51 millimeters, so I have to readjust it further. So now my third focusing attempt puts it at 54 millimeters, which is a real good outcome. With a room such as this, it can be useful to do it with two people, one person to stand by the chart to tell when the letters are in focus, and the other person adjusting it at 20 feet away to get the settings just right. And the two can talk back and forth to help get it to the proper focus. The other thing is getting the chart level so that the image is level. If tilting this chart a little, you can not only move it up and down, but you can twist it sideways so it's out of alignment. And so once you get it in the proper position, then you can snug up the bolts the rest of the way. So this version is a mirrored room with the projector and the screen behind. Now, as you see here, all the letters are reversed, whereas with the mirror, it's all straightened out. Another form of chart are these hang-on-the-wall type charts. Now, in an emergency, you could have a 20-foot room and use this as the chart. And you probably have to have some sort of a flashlight or pen light that's just shining up lighting up the line you want them to look at. In a mirrored room, that wouldn't work so hot, except if you had a reverse chart for an emergency, like your projector went out suddenly. So this room is approximately 20 feet with the mirrored effect, and here's a reversed chart sort of hung in place, and you could actually take acuities with this if you light up the cardboard chart. This reversed chart is sold by Western Optical, or made by Western Optical. "30 years ago, the standard was the Reichert manual projector. This type mounted on the floor, other types mounted on a wall with an extra bracket hooking up to this and then attaching to a wall. This one still a floor model. You have to do the same sort of setup for calibration. Measuring out a 2200 letter, it's supposed to be 53 millimeters or so for this room, and here we're up to like 66 millimeters. This projector has a similar effect, focusing part of the tube, and then actually I guess this one is telescoping, and there's a screw connection on the bottom, and this one focusing or telescoping on the front, so these need to be both made so that they can be adjusted. Twisting it in, and then moving it out to focus, and that adjustment made it even bigger. So it's obviously the other direction, telescoping this out. After several attempts of telescoping and refocusing, it's now about 55 millimeters, which is ballpark to refract with this, and you can see how the tube here is now substantially telescoped out, and this one is a very different position from where we started. But that's how you change the size of the image. Similarly, using this type of projector, which you could then use in a pinch if one of your electronic models failed. So this is a printout I made for pre-calculating out the size of the 2200 letters based on the chair to chart distance. If you want a PDF of this, if you scroll below the video frame of this video you're looking at, and then click the Read More link, it will open up the narrative section, and then you'll find a link to find this document. Basically, there's printed material, a link for printed material in the narrative section of this video, and you can then go to that site and download this calibration chart. So many rooms will have a metal screen on which you project the image. This is also a metal screen, however it's also steerable with these connections behind the mirror, and this is mounted in the wall, and then we can tilt this metal screen to get the maximum brightness. So where the patient is looking at the chart, they'll have the maximum acuity that you can get out of the chart by having proper reflectivity from this image. Another factor in setting up a chart is the brightness of the image that's being projected onto the screen. Now this is a metal screen which has some reflective characteristics. The idea is to make it brightest for where the patient is sitting. This is also a steerable screen, which can be pivoted to different angles. So as I was saying, the brightest point should be where the patient is sitting, and if the tilt of this changes, it actually dims and distorts. But the idea is to make the brightest illumination where the patient's looking at the chart, which is achieved by changing the angle of this to reach the optimum reflectivity where the patient is sitting, as well as getting the shape of it right. If it's tilted way up, you've got a distortion problem. If it's tilted way down, you've got a distortion problem. Or if it's way too far off to the side, you've got a distortion problem, as well as bad illumination in all those positions. This is a computer screen chart. The way this is calibrated, you need a mouse and a keyboard. By pressing the Z on the keyboard, it pops up this display. This is a room which has a direct view from the exam chair. And the distance 1 here is the one that is calibrated for, 16 foot 0 inches. Part of the calibration is to make sure that the display is properly calibrated. So this display button, you click it with a mouse, and then you get this black square. If properly calibrated, it's supposed to measure 10 by 10 centimeters, which you can see it does. And if it's not, then you need to increase or decrease the pixel height and width to get to the proper calibration. And when that's done, you click the Done button, and when all the settings are correct, you click the Done button again. This is set for a blank screen timer of 60 minutes, which means in 60 minutes, if you haven't touched any of the controls, the screen will go blank. And then when you're all done here, you just click the Done, and that brings you back to the acuity letter, which in this case is a 2200 letter. And this happens to measure about 70 to 71 millimeters for a 16-foot calibration. Without having this page, it can be done by calculation. As long as you remember the 2200 letter should be 87.24 millimeters. You can then do it proportionally to figure out what it would be for a 16-foot room. Smaller in size, 16 divided by 20 times 87.24 will give you the end result. If it's a 22-foot room, you would go 22 divided by 20, which gives you something bigger than the original number of 87.24. Using that in a calculator will give you the larger size, which you can see here should be about 96 millimeters in height. So I've checked the calibration of probably 50 or more of these computer screen charts, and this is the usual configuration. There's typically an on-off button here. There's usually 3 or more USB ports that you can plug in a keyboard and mouse to help you calibrate the chart.
Listen, it kept me up all night last night.
So I've only seen one of these style of M&S charts. This is about 2.5 inches wider screen and about 2 inches taller for the height. But there's no visible on-off switch in the front of the screen. There is a an on-off switch here which will turn off the chart, but it doesn't actually turn the chart back on, at least not fully. So you switch to the O side and then it's off, and then you put it back to the 1 side and it's back on, except the screen doesn't come back on. I had to call up the M&S company to find out how to get it restarted. He said, oh yeah, look for a silver button on the right side on the bottom, and so then you have to press in this start button to make it start after it's been turned off or unplugged. The other problem is this has only 2 USB ports, and one of them is actively in use by a component from the computer screen chart. This has to be plugged in to make it work, and this one is a mouse that the doctor had plugged in because it's necessary to click certain boxes if something goes wrong. But you need 2 USB plugs in order to calibrate it. And so I've brought in a device that's got a USB hub on it, so I can split into 2 plug-ins. So again, this is the largest screen that I've seen. It's like 18.5 inches wide and about 12 inches high net screen area. And the chair-to-chart distance is 24 foot 2 inches, since it's a mirrored room from chair to mirror and then back to the screen. Now this room originally had a platform here for a Marco CP 690E projector, which went to this mirror and then back to a metal screen here, but it was one of the dimmest views because again it's spanning more than 20 feet, an extra 3 feet, so 27 feet round trip for the projector, and the computer screen chart ends up working out much better in this room. But it had to be large enough, I guess, to have sufficient images for the larger letters. So the M&S screens, visual acuity screens, have a lot more complexity than the standard projector, the manual projector, or paper eye charts. It's a computer-driven device, and it's also extremely complex technical-wise. The advantage is that you can have a different acuity line every time you test somebody. That is, each time, let's say you're showing a 20/20 line, you press the 20/20 button a second time and it gives a different series of letters, still of 20/20 size, but the patient can't really memorize one line after another because you can deliberately display different lines of letters all of the same size. They randomize them that way. Now we also found out is after some of these M&S charts were in use for 5 or more years, we hooked them up to the auto Phoroptors, and suddenly they were out of calibration. That is, what appeared on the auto Phoropter screen was not what was on the displayed image on the M&S screen. And so we then had to get back online, phone line basically, with the M&S people, and they would have us put specific commands and click certain boxes on the M&S screen when we were trying to calibrate it properly to be compatible with the auto Phoropter. So there's a lot more complexity that goes into it. When it works great, it works great. But when it gets out of calibration, it's much more complex than your typical projector. This is an Apple computer screen chart, and I believe it was made for Lombard to sell. But it's got the Apple logo here. So if you select an acuity line, just like with the M&S chart, you press the same number again, and it gives you a different array of letters each time. So there's no way that the patient can possibly memorize all the different random combinations you can throw at them. And this is the remote control that goes with that computer screen chart. So the USB ports are behind the screen. I just plugged in a mouse and a keyboard. Now for calibration, pressing the H key. So pressing the H key pops up this display, and then I click the calibration selection. And here it says that's the chair to chart distance in feet. And then you're supposed to measure this square, this rectangle. So the display says it should be this height, and I just confirmed it by measuring with the PD ruler that it agrees with that measurement. Then I pressed the H key, and then the calibration narrative on the side disappeared.